Welcome fellow learners. In the last video, we explored reducer functions, what they are, how they work, and how they help manage and merge state in LangGraph workflows. In today's video, we are going to take that concept into a real-world use case by building a custom RAG agent using LangGraph. We will walk through the entire pipeline step by step, starting from data pre-processing all the way to generating the answers. So what you are seeing right now is the complete graph flow of a custom RAG agent which we will be building in this tutorial using LangGraph. So firstly, user will ask a query. That query will be passed to a classification node which will decide whether to simply answer the user question directly or it needs to retrieve the additional context from a vector store. So if classification node has decided to fetch additional context, it will use a retriever to fetch documents using a similarity search. The retrieved documents are then graded in parallel using the send API to check if the documents are relevant to user's query or not. And then it will use a reducer function to merge those grading results in this particular grade documents function. After that, collect docs node will collect all the relevant documents. So once the grader has provided the relevant documents, we will use the question and the selected document to generate the final answer using this generate answer node. And our graph will end here. But if none of the documents are relevant, the agent will rewrite the user's query intelligently using an LLM with the help of this rewrite question node. So as the question was reframed, our graph nodes needs to rerun. So it will again run the classification node, retriever, grader and collect docs node, and then only it will be able to generate the final answer. So this is the graph that we will be building. By end of this video, you will understand how to design a complete RAG agent pipeline and how reducer functions make it all work smoothly behind the scene. So let's dive in and I will walk you through how to build this graph from scratch. So in the first step, we are going to pre-process the document. For the document part, we are going to utilize a blog from Hugging Face. So this is the blog and it is titled as Vibe Game Exploring Vibe Coding Games. So to load this document, we are going to utilize web-based loader from LangChain community. And after that, we will be using recursive character text splitter to split this document in chunk size of 500. So over here, you can see I have mentioned chunk size equals to 500. So let's run these cells. Firstly, let's run this cell to load these two, web-based loader and recursive character text splitter. And after that, we can use web-based loader's load function to load this particular document. So once this blog or document has been loaded, we can use recursive character text splitter and create an object of it. You can see over here I have created this text splitter object, and then we can use split documents function from it to split this document. So let's run this cell. Once it has splitted the document, we can see how many chunks it has created. So we can print the length of this particular variable doc splits. So you can see it has created 8 chunks of size 500, and let's just print 0th index of this doc split document. So over here you can see text of the document and it has created 8 chunk of size 500. So now in the next step, let's create our classification node. As I have already told you, this classification node will play a pivotal role in our graph. So based on the user's query, the LLM will decide does it need to fetch additional document from the retriever tool or it can answer the user's query directly. So for that part, let's first initialize our LLM. Over here, you can see I am using GPT 4.1 Nano model for the LLM part. I passed the OpenAI API key over here. I saved OpenAI API key in my environment variable. So let's run this cell and it will initialize the LLM. Now, once the LLM has been initialized, let's define our classification node function. So over here, you can see I have created this generate query or respond function, which will be treated as the classification node in our graph. Now, to make sure that LLM has the knowledge of what it needs to do, I have created a classification prompt over here and I have defined that you are a classifier. Given the current state, you will decide to retrieve from the retrieval tool or simply respond to the user's query if the question is general. And I have provided the state to it. Apart from that, you can see I have also defined a classify class which is inheriting from the Agentic base model. The reason for creating this particular class is to make sure that LLM provides the output in a particular structured format. So over here you can see the result which we want is a string, and it should only return either a retrieve value or a response value. So if it returns a retrieve value, our next step would be to fetch the information or fetch the additional document from the retriever tool, or if it replies as response, LLM would be able to respond the user's query directly. Now over here you can see I'm using this with structured output with LLM to make sure that the output from the LLM is in a particular structured format. I'm passing this classify Agentic base model class to this with structured output. This particular with structured output is a wrapper around our LLM model to make sure that it returns a particular structured output format. So let's run this cell and it will define our node. So now in the next step, let's initialize the retriever. For the retriever part, we are going to utilize in-memory vector store from LangChain core. And for the embedding, we are going to utilize OpenAI embeddings. And let's run this cell to initialize these two modules. And over here, you can see I'm using text embedding 3 small from OpenAI embedding and passing OpenAI API key, which I have stored in my environment variable. So let's run this cell and it will initialize the embeddings. To test if it is working correctly or not, we can pass a simple query to it. Let's say we are passing just a hi message to it. What we can do embedding.embed query and pass a simple message like let's say hi, and it will provide the embeddings of this hi particular message. So over here you can see it has provided a list of numbers, and we can see it has given the embedding of that hi message. Now over here you can see I have created a variable named vector store with the help of in-memory vector store, and I am utilizing from documents function from it. And you can see in this from document function, we can pass the documents. Those documents should be a list of document and embeddings. So for the embedding part, I'm passing that OpenAI embedding. And for the documents part, I'm passing docsplit, which is just the splitted document. And that document is split into 8 chunks. And each of those chunks are having size of 500. So let's run this cell. And you can see I'm using this vector store and using it as a retriever, and over here I passed search type as similarity such that when it will try to fetch the relevant documents from that vector store, it will use cosine similarity to search. Now over here I have passed k equals to 3, which will make sure that it will only return the top 3 documents from the vector store. So let's run this cell and now we can test it. Let's invoke this particular retriever with a simple query. So let's say as that blog was related to vibe coding, so let's pass what is vibe coding and let's see the result. Okay, so let's run this cell. Now you can see it has provided these results, and you can see it will only provide 3 results. The first one is this, second one is this, and third one is this. So we can see it is working fine. Now after that, you can see I have created this vector search function. This vector search function will be treated as our retriever node in our graph. So you can see I am fetching the question from the state, that will be the user's query, and passing that question to a retriever tool, that retriever that we have defined earlier, and the context or the number of documents which we have seen, these 3 documents which it will provide at the runtime, will be returned from this particular vector search function to the key context. So what will happen? These retrieved documents will be passed to this particular context key in the state. So let's run this cell and it will create our retriever node. So now in the next step, let's define our grader node. So as we have seen, our retriever node will fetch top 3 documents from the vector store. Now what this grader node will do, it will grade each of those 3 documents which it has fetched from the retriever node and make sure that each of those documents are relevant to the user's query or not. So you can see over here for the grading part, I have asked the LLM to provide a binary score, either yes or no. If the document is relevant to the user's query, the LLM will provide the result as S, or if the document is not related to the user's query, it will provide the no. So for that part, I have also provided a prompt. So I have given the specific prompt to the LLM that it is a grader which will be assessing the relevance of the retrieved document as per the user's query. So let's run this cell And once again, this grade document class is defined and it is inheriting from the pedantic base model, and it will make sure that the LLM would provide a particular structured formatted result. Now over here you can see I have defined this grade documents function. This will be treated as node in our graph, and it is fetching the question and context from the state, and that question and context will be passed to this particular grade prompt which we have defined earlier over here. And based on these two things, context and question, context would be one particular document from the retriever tool, and the question will be user's question, and it will be passed to this LLM. And finally, LLM would provide a structured output which we have defined in this particular grade documents class. So it will either provide yes or it will provide no. So we are passing the response based on the result we got from the LLM in this grade documents function or grade documents node. So over here you can see if the response is yes, what I am doing in the validated context, I am appending that particular context which we have fetched from the retriever tool. And if the LLM has provided that the response as no, that this document is not relevant to the user's query, I am just returning an empty list. So let's run this cell and it will define our grader node. Now over here you can see I have defined a separate function context reducer. What this function is doing? This function is using send API from LangGraph, and the purpose of using this send API is to make sure that grading those three documents can be run in parallel. So instead of running sequentially, this send API will make sure that grading of each of those three documents can be run in parallel. So let's run this cell and it will define this function. And what will happen if you hover over this particular send API, and you can see it requires node and argument. So for the node part, I have passed grade documents, this particular function, and for the arguments, I am passing these question and context, two things, and this question and context are getting fetched from this particular response. This is the response which we get from the retriever tool. So this retriever tool will be having three documents, and those three documents will be passed in parallel to this particular grade documents function. So in this way, this send API will make sure that grading of those three documents can be run in parallel. So now in the next step, let's define our rewrite users question node. So in case of none of the documents are relevant to the user's query, what we can do, we can pass the user's question to the LLM and ask it to rewrite in a way that it can fetch relevant documents from the vector store. So what you can see over here is that I have defined a rewrite prompt, like look at the input and try to reason about the underlying semantic intent or meaning. So here is the initial question, and I have provided the question to it, and then I have asked it to formulate an improved question. And after that, I have defined this rewrite question function. This will be treated as node in our graph. I have passed the user's question to it over here, you can see, and pass that question to our prompt, and which will be passed to our LLM, and LLM would provide an improved question, and that question will be returned to the messages key of the state of the graph. So let's run this cell and it will define our rewrite question node. So now in the next step, let's create one more node which will be our generate final answer node. So over here you can see I have created a function named as generate answer and pass the user's question and the context which it has retrieved from the retriever tool. And I have created this generate prompt over here and provided some context to it, like you are an assistant for question answering task, and I have provided a question and context to it. So let's run this cell and it will create our prompt. Now let's run this cell to define our generate answer node. It will be used in our graph as to generate the final answer which will be shown to the user. So now we have created all the nodes. So let's assemble this graph. So to assemble this graph, let's first import few modules. So let's run this cell. And now let's create the state for the graph. So over here you can see I'm using message state, which will make sure that messages key is already provided in this graph state class. And apart from that, I have created two more keys. The first one is validated context. The second one is retry counter. This validated context we have already seen. We will be using this validated context to make sure that when we run that grader, that validated context key is updated based on the documents which are relevant to the user. So data from this validated context will be used to pass into our LLM to provide the final answer. And the second one is retry counter. This key will be required to make sure that our graph or our agent doesn't run in an infinite loop. So let's run this cell. And now let's create few conditions which we will be using in our conditional edge. So the first one is retriever condition. Second one is this validate context. So what will happen in this retriever condition? So as we have seen in our classification node, it will only provide either of two results, either retrieve or response. So if the LLM provides in that classification node provides retrieve, what this retriever condition will do, it will return retrieve. And if that classification node has provided response as a result, it will return just the response. And next in the graph, I will show you that I have used these two things, retrieve and response, as the name of the nodes. So what will happen? So if this retrieve condition function or condition will return retrieve, it will directly call the retrieve node and it will call our retriever tool. And if this particular condition returns response, what will happen? It will just provide the answer directly. So let's run this cell. Now there is another condition, that is validate context. So over here you can see this condition only returns two things, either a rewrite question or just the response. So what will happen if in the validated context key we don't have any document, and what might have happened is that our grader doesn't find any of the document relevant to the user's question. In that case, we will try to rewrite the question with the help of LLM. So for that part, we will be sending rewrite question from this particular validate context function. And if that validated context key has some documents in it, and that grader has seen that few of the documents are relevant to the user's query, we will pass those relevant document along with the user's query to our LLM and to this particular generate answer node, and it will provide the final answer. So let's run this cell. And after that, I have just created another node, which is collect docs node. It will make sure to collect all the document as we are using send API, which will run our grader node parallelly. And when it will be running parallelly, this particular collect docs node will make sure that all the responses are retrieved. Until all the responses are not retrieved, this collect docs will not run the next node. So that is the function of this collect docs. One more thing you can notice that I have updated this retry counter with +1, such that it will make sure that the number of times our graph has run. So let's run this cell. Now over here you can see I have defined the complete workflow. Firstly, I have added all the nodes to our workflow. Generate query or respond, this is our classification node. Retrieve node, which will be fetching the relevant document from the our vector store. The grade document, this will make sure that the retrieved documents are relevant to the user's query or not. Generate answer, this will generate the final answer to the user. Rewrite question node, this will rewrite the question and it will try to improve the question if our grader node has find out that no documents are relevant to the user's query. And finally, this collect docs node, which will make sure that until all the responses from the concurrent call to that grader has not been received, it will not run the next step. These are the nodes that we have defined, and after that there are few edges. So let's run this cell and let's see how it will define in our graph. So this is our complete graph that we have created. Now let's test this graph to few examples. So let's first run a simple question which is related to the document which we have provided to the LLM. So I'm asking just a simple question, what is Y coding according to the block? And now over here you can see I'm also passing this retry counter. At the start, the value for this retry counter will be 0. So let's run this cell and let's see the result of the graph. Now at the start you can see query for the vector store search, and it has provided the query as what is Y coding according to the block. This is the query which we have passed. Now you can see responses from the grader. So for the first two documents, it has provided as yes, and for the third document, it has provided the value as no. Now in the generate answer node, only these two documents will be passed to the LLM. And over here, you can see at the collect docs node, retry counter has been updated. And we have received the final answer that vibe coding as defined in the block is using AI as a high level programming language to build projects. And we can clearly see that it has fetched the result from the block. So we can see that our graph, our this drag agent is working perfectly fine. Now let's run a few other questions. So let's say we are passing just a query, which is just a general query. So let's say, hello, who are you? So let's run this cell. Now, as we have created the graph, this query should not fetch any document from the vector store. And clearly over here in the response, you can see it has not fetched any document from the vector store. We can also print the state of the graph. And over here, you can see we have asked this question, hello, who are you? And after that, in the classification node, we can see that it has provided the result as response. And due to this response key, the LLM has decided to answer it directly instead of fetching the documents from the vector store. And if you compare it with the response which we have received earlier, this particular response, let's see that also, see the state of that also. So over here you can see at the start, this is the query that we have passed to the graph, and after that it has provided this retrieve key from that classification node. Due to that retrieve key, our graph is running that retriever node uh, which is fetching the documents from our vector store. Over here you can see the documents which it has fetched. So clearly we can see that our graph, our this RAG agent is working perfectly fine. So great, we have created the custom RAG agent from scratch. You can modify the nodes as per your own use cases. So in the next video, we will try to add memory to our agent using LangGraph. So thanks for making till the end of this video. Goodbye until the next time.